the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, I will review the concepts of intercepts of graphs, roots of equations, and zeros of functions. Believe it or not, these topics are all intimately related, so let's get started. In algebra, we commonly deal with two-dimensional graphs, so we only have two axes, the horizontal and the vertical. Yes, there are advanced cases where the axes are not perpendicular to one another, but we're not going to go there. In this case, the horizontal intercepts occur when our curve strikes the horizontal axis. According to this graph, that happens at the points 2/3, 0 and -1/7, 0. Notice I'm stating the horizontal intercepts are points. Some instructors would be fine with students saying the horizontal intercepts are 2/3 and -1/7. However, this is not technically a proper response. It would be more appropriate to state the horizontal intercepts are 2/3, 0 and -1/7, 0. Likewise, the vertical intercept, where our curve strikes the vertical axis, is 0, -2. As a side note, math students are often asked for the x or y intercepts. If the variable associated with the horizontal axis is x or the variable associated with the vertical axis is y, then asking for the x or y intercepts is the same as asking for the horizontal or vertical intercepts, respectively. It is rare in applications for your variables to be x and y, so it's often better to just call these the horizontal and vertical intercepts. Now, if you turn your head while looking at this graph, the perspective of which axis plays the role of the horizontal and which plays the role of the vertical swaps. So you could argue that the wording horizontal axis and vertical axis is relative to perspective. This is technically true, and if it presents a problem for your brain, just refer to them as their variable axes. That is, this right here would be the w-axis, and this other one would be the t-axis. This is especially useful when dealing with higher dimensional graphs. Consider this three-dimensional graph. The verbiage horizontal and vertical begin to lose significance when you move into higher dimensions because of how complex the graphs get. For example, in this perspective right here, the x-axis looks to be horizontal, but once we rotate the perspective, this axis is no longer horizontal, nor is it vertical in this case. Thus, it's just best in higher dimensions to refer to the axes by their associated variable names. That is, this would be the x-axis, this other one right here would be the y-axis, and finally, we would normally call this last axis the z-axis. When intending to ask to find the horizontal intercepts of a graph, some instructors will incorrectly ask to find the roots of the graph. If you're an instructor watching this video, don't get too offended. I actually make this innocent mistake every once in a while. Let's investigate why this confusion occurs by looking at the definition. Notice that this definition doesn't mention anything about a graph. Roots are associated directly with equations, not graphs. As a simple example, someone can hand us this equation, and we could do some mathematics in the background and find out that the roots of this equation are x equals 2/3 and x equals -1/7. However, suppose we are asked instead to find the horizontal intercepts for the graph of y equals 21x² minus 11x minus 2. Since the horizontal intercepts occur when y is equal to 0, we're essentially being asked to solve our original equation. Therefore, we find the horizontal intercepts to be 2/3, 0 and -1/7, 0. This is why many people use the word roots and the phrase horizontal intercepts synonymously. They aren't actually the same thing, but they lead to the same result. So there isn't any harm in confusing the two as long as you remember that the roots of an equation are associated with the horizontal intercepts of its graph, not the vertical intercepts. You might also read in a text or hear from your instructor the phrase, find the roots of the expression. Remember, the roots of an equation are the values that solve it, but the roots of an expression are the values that turn the expression to 0. Thus, the roots of the expression 21x squared minus 11x minus 2, notice no equal signs, are x equals 2/3 and x equals negative 1/7, because these values will cause the expression to become 0. So it's looking like the word root has several meanings or uses in mathematics. However, all these meanings and uses end up being identical. Solution to an equation, root of an equation, horizontal intercept of the graph of an equation, root of an expression, and value that causes an expression to become 0 all lead to the same result. We've talked about roots of equations, roots of expressions, and intercepts of graphs, and how these are all intimately related. However, we have not mentioned functions. As you can see, when it comes to functions, we stop saying roots and start using the word zeros. Other than that difference, the work is the same. Thus, if asked to find the zeros of the function f of x is equal to 21x squared minus 11x minus 2, by definition, these occur when the function is 0, so we still want to solve that same equation we keep running back into. As we already have computed, the solutions to this equation occur at x equals 2/3 and x equals negative 1/7. Would you be incorrect if you said you found the roots of a function or the zeros of an equation? In my opinion, while it's technically incorrect verbiage to use roots when talking about functions and zeros when talking about equations, the intention is correct. So I don't have an issue with that small abuse of language. It's akin to people who say, here's a factoid, when they mean, here's a small fact. A factoid is actually a false fact, but I think that most people don't know this, and factoid as a word has taken on the incorrect urban meaning of small fact. So I'm not that guy who steps into someone's conversation after they say, here's a fun little factoid, to admonish them, a factoid is a false fact, so you're basically just telling us a lie. Thank you for watching this review video on intercepts, roots, and zeros. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Names for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.